Okay, so this is our last video dealing with transformations, and this deals with one that's called non-rigid transformations. And they're called non-rigid transformations because all of the other ones we've done so far have just been moving the graph or reflecting it. This is actually going to stretch or shrink the graphs here. And so there are, basically we can have, if h at x is equal to c times f at x, so this is where we are doing the parent function first and then multiplying by c. This is vertical stretching and shrinking, and this is a vertical stretch when c is greater than 1, and it's a vertical shrink. Now you might think it's going to be negative, but it's not. These are actually, c's are going to be always positive, and it's between when c is basically a decimal number, 0 to 1. And we also have a horizontal stretch and shrink, and you might guess that this is when you have f at c times x for your function, and this is the exact opposite. This is a horizontal shrink when c is bigger than 1, and it's a horizontal stretch when c is between 0 and 1. Now, what I like to think about here, and I'm just going to draw a sketch of an absolute value function. I'm not even, I'll go ahead and bring up my graph here. Now, what I like to think of it is here, I'm just going to draw absolute value because I think it's the easiest one to illustrate what it is. And the reason I think it's the easiest one to illustrate is that often in these functions you can have it be represented as either a horizontal shrink or a vertical stretch. So if we're talking about a vertical stretch here, I like to think of it as, okay, now you don't have to do this, but like for instance, attach a bar here. I'm just drawing a dotted, and then pull this bar up. And so the resulting graph is going to be something like this for a horizontal stretch. But basically this is the same thing as a horizontal shrink, because if I'm talking about a horizontal shrink, you're basically squeezing in on both sides. Like if you were closing it up on both sides, you'd get a horizontal shrink. And the other one, of course, is the vertical shrink, which would be, instead of having this bar being pulled up, we'd be pushing this bar down. And if we did that, we would wind up with something like this here. For the vertical shrink, because I'd be pushing down. Now this would be a horizontal stretch because I'm pulling apart. So as I said, you can often represent these as both horizontal or vertical. So let's look at one or two quick examples here. I think we might only do one example here because the vertical, the non-rigid transformations, it's a little bit more just having to do kind of equation plug and chugging here. So let's look at h at x equals 1/2 x squared. And just like we did on all these before, we're going to want to sketch the parent function. and then sketch the transformations that applied. So parent function 0, 0, 1, 1, negative 1, 1. And we don't, normally when we do the parent functions, I just draw them as dots here. So this is my parent function. Now, as I said, the way this is written, we would think of this as a vertical one, although technically we could rewrite it, and I'll show you in a second on that. This would be a vertical, but since it's the constant is less than 1, this would be a vertical shrink. So this is a vertical shrink. And then we say by a factor of 1/2. And so all we literally do is take all the y values and make them 1/2. Well, half of 0 is still 0. Half of 1 is 1/2, of course. So those would be there. And half of 4 is 2. So we still kind of get a parabola-esque shape here. Well, it's still a parabola, not parabola-esque. But we can see what's happened is we've kind of stretched it, flattened it out a little bit. Now, the way you could think of this, and it's not necessary to, but the way you could think of h at x as a horizontal shrink is 1/2 x squared is the same thing as 1 over the square root of 2 x quantity squared. And then that would be a horizontal stretch by a factor of 1 over the square root of 2. Now, typically we don't want to necessarily think about it because that way, because then, well, that would mean you'd have to move the points out to the left and right by 1 over the square root of 2. So, which is definitely not as easy to do. Now, if it was moving the points out by like 3 or something, okay, that would be fine. But you want to pick the one that's going to be the easiest. All right, let's look at one more here. And just like we had before, we can combine these together. And so we're going to have this be g at x is equal to the square root of 3x plus 1. And so remember, the only one we have to be careful about with following the order of operations is that weird y-axis reflection with a horizontal shift. All the other times we just follow order of operations. And so what we have here first is, well, the parent function is square root of x, and then since the 3 is associated with that in there, we get a horizontal, and this would be shrink by a factor of 3. Now, this one, sometimes the way we look at these, sketching the parent function isn't always necessarily the easiest thing to do here. So we'll still do that. I mean, sketching the parent function is easy to do, but then applying the non-rigid transformation of the parent function isn't always the easiest thing to do. And so, you know, the parent function, of course, is 0, 0, 1, 1, and then 4, 2. So a couple of these would be pretty easy. If we're shrinking or shrinking by a factor of 3, well, this is still going to be here. But then if we're talking about if moving this point over by a factor of 3, what does that really mean? So that's where it gets a little confusing, I think. And so what we can do instead of just is simply plug in some numbers. and think of what they are, because moving it by a factor of 3 over here would be, well, for instance, moving it by a factor of 3, you could just say divide that by 3. So you're shrinking by a factor of 3, and that would be then roughly right here. And if you think about it, what is this roughly here? I'm thinking of this being 1/3, because I'm shrinking by a factor of 3, so I'm doing 1/3. And the reason it's 1/3 is because, well, 1/3 times 3 is 1, so square root of 1. Okay, and well, this would then get moved to, well, this input is 4, so it'd be 4 divided by 3, which is 1.33, so that'd be like roughly right here. But then it's still kind of like, okay, well, what does the graph look like then here? Well, an easy one to also plot in here is just 3. Just plot it in. 1, 2, 3, because 3 would simply be x equals 3. You'd have the square root of 9, which would be right there. But we did go ahead and just shrink by a factor of 3. We moved them to the right here by a factor of 3, so we divided by 3. And so that's what we'd get here. So we'd have, well, I'll draw dotted lines here because this isn't my full function here. So I've got those now, but then what do I have to do? I have a vertical shift up by 1. And so the final graph would be moving all those points up 1. And so that would be the final graph, and actually it would probably be more like this. So as I said, some of these can be a little bit more challenging with the non-rigid transformations, but just you'll have some practice, and just more practice, you'll get better at them. So this wraps up our videos on transformations of functions. So quite a bit that we've gone over. We're now going to talk about combining functions after this. This next video we'll be doing is talking about the combination of functions.